In this video, we're going to continue on with examples. So in the previous video, we talked about wholes being whatever you canceled, the factors that you canceled, set it equal to 0, solve vertical asymptotes, whatever's left over in the denominator, you set everything equal to 0 and solve for x. Those are also going to be your excluded values. Now I'm going to go through all of these examples, and the way that this is written out is exactly how you're going to also see it on the assessment. So the homework is going to look a little bit different, but the assessment looks just like this. So for this number 2, we're going to simplify 4x squared plus 8x divided by 12x plus 24. So to start with, you're going to take this entire thing and you're going to factor it. So in the numerator, I'm going to GCF 4x. What's left over in the numerator, in parentheses, x plus 2 divided by, in the denominator, you're going to GCF again. I'm going to pull out a 12. What's left over in the denominator's parentheses is going to be x plus 2. So in here, I'm able to cancel the x plus 2 with x plus 2. So what we have left over is 4x divided by 12. From here, I'm going to simplify. We're going to reduce. 4 over 12 reduces to 1/3, or x over 3. And this is actually your final answer. So that's how you simplify. The next thing that you're going to do is you're going to take whatever you have crossed off, which is x plus 2, and I'm going to set that equal to 0. So we have x plus 2 equals 0. You're going to solve and you're going to get that x equals -2. That's your whole. You're going to write down that -2 is an excluded value also. Now, what's left over in the denominator is what you set equal to 0. However, 3 equal to 0, this does not work. So you don't have any vertical asymptotes. So you just leave that blank. Number 3. So I'm going to start by factoring. So we have x plus 2, x plus 2. And in the denominator, I'm going to factor that. It's a difference of squares. We have x plus 4, x minus 4. Nothing cancels, and this can't reduce any further. So this is actually your final answer. So in this problem, since I didn't cancel anything, I don't have any wholes. However, you are going to take what's left over in the denominator and set that equal to 0. So now I have two things. So we have x plus 4 equals 0, and then we have x minus 4 equals 0. So I'm going to subtract 4, and we get that x equals -4. So that's one of my vertical asymptotes. And then I'm going to add 4, and then I get x equals 4. So that's another one of my vertical asymptotes. So those are also going to be my excluded values, -4 and 4. No holes for this problem. Number 4. In the numerator, that's not factorable, so we just leave it as x minus 3. In the denominator, two numbers that multiply to -18 but combine to a +3. So again, multiply to -18, combine to a +3. That's going to be 6 and 3. And in order to get to -18, one of them has to be negative. And again, to get to that 3, one of them has to be negative. If I make the 3 negative, it works. So we have x plus 6, and then we have x minus 3. I'll go ahead and erase that. From here, I can go ahead and cancel the x minus 3 with the x minus 3. So we're left with 1 over x plus 6. And this is your final simplified version. From there, we're going to write down our wholes and excluded values. So what I canceled was that x minus 3. So I'm going to take x minus 3 and set it equal to 0. And we get x equals 3. Then you're going to take whatever's left over in the denominator, set it equal to 0. We get that x equals -6. So we have excluded values of 3 and -6. So they're both excluded. In number 5, we're going to simplify. So in the numerator, I'm going to pull out a GCF of 5. What's left over is x plus 5. In the denominator, you're going to factor. It's a difference of squares. So we have x plus 5, x minus 5. From there, you can go ahead and cancel. I'm going to cancel x minus 5 with x plus 5 with x plus 5. So our simplified version is 5 over x minus 5. So now we cancel that x plus 5, so that's going to be our whole. So I'm going to set x plus 5 equal to 0 and I get that x equals -5. For my vertical asymptote, it's whatever's left over in the denominator. So we take x minus 5, set it equal to 0, and we get x equals 5. So we have an excluded value at -5, and then we have another excluded value at +5. Number 6, I have to factor the numerator and denominator. So in the numerator, I'm looking for two numbers that multiply to 4 but combine to 5. 4 times 1 is 4, and 4 plus 1 is 5. In the denominator, you're looking for two numbers that multiply to 20 and combine to 9. Four and 5 multiply to 20, and they add to get to 9. So from here, we're able to cancel x plus 4 with x plus 4. I'm going to write down what's left over, which is going to be x plus 1 divided by x plus 5. So this is my simplified answer. That's your final answer to this problem. Your whole is what you cancel. So I'm going to take x plus 4 and set it equal to 0, and we get x equals -4. And then I'm going to take what's left over in the denominator, which is x plus 5, set it equal to 0, and we get x equals -5. So you never, ever, ever set the numerator equal to 0, ever. And your final answer for excluded values are -4 and then -5. In number 7, I'm going to leave that numerator as is because it's already factored. In the denominator, I'm going to factor, this is the difference of squares. So we have x plus 4, x minus 4. All right, so nothing cancels. However, I noticed that this x, 4 minus x, is the opposite of one of these. All right, so what we're going to do is pull out a -1. And when I pull out a -1, the 4 is now -4, and then now the negative x is plus x. Divided by, we have x plus 4, then we have x minus 4. So we have to figure out, okay, which one matches -4 plus x? One that matches that -4 plus x is x minus 4. They're the exact same thing, just different order. So our final simplified version is going to be -1 over x plus 4. From there, you're going to take what you canceled. So we canceled x minus 4, set that equal to 0, and we get x equals 4. And then you're going to take whatever's left over in the denominator, which is x plus 4, set that equal to 0, and you're going to get x equals -4. So those are your excluded values, 4 and -4. Number 8. Factor two numbers that multiply to -14 but combine to -5. It's going to be -7 and +2. Two numbers that multiply to -16 and combine to -6. It's not going to be 4 and 4. You're going to use 8 and 2. So we have x minus 8, x plus 2. From there, you're able to cancel. I can cancel the x plus 2 with x plus 2. So our final answer to the simplified rational expression is x minus 7 divided by x minus 8. Going to box that up. So let's do our whole. I cancel the x plus 2. So I take x plus 2 and set it equal to 0, and you get x equals -2. You're going to take whatever's left over in the denominator, set it equal to 0, and you get x equals +8. So your excluded values are -2 and +8. For number 9, this is a good one because number 9 includes GCFing before you factor. So for number 9, what I'm going to start by doing, x cubed, x squared, and 42x all share an x. So I'm going to pull out an x. It doesn't disappear. You just GCF, and we have x squared minus x minus 42. In the denominator, x squared, x, and then no x, so no variables. However, they're all even. 2, 20, and 42 are all even numbers, so I'm going to GCF the 2. And when I do that, what's left over is x squared minus 10x plus 21. Now we can go ahead and continue factoring. So we keep that x on the outside in the numerator. And two numbers that multiply to negative 42 combine to negative 1. It's going to be negative 7 and positive 6. In my denominator, leave the 2. Two numbers that multiply to positive 21 combine to negative 10, negative 7, and negative 3. From here, I can go ahead and cancel out x minus 7 and x minus 7. So my simplified answer is going to be x times x plus 6. They're both left over in the numerator, divided by 2, and then we have x minus 3. Even though 6 is even and 2 is even, they're not able to reduce, okay? The 2 is on the outside, 6 is on the inside. It's also connected to the x plus 6. So unless I have something fully to cancel with x plus 6, you cannot reduce, you can't cancel. So this is my simplified answer. My whole, you're going to take what's you canceled, x minus 7 equals 0. We get that whole is at x equals 7. My vertical asymptote is what's left over in the denominator. So if I said 2 equal to 0, this doesn't work. So 2 is not part of my answer. We take x minus 3, set that equal to 0, and you get x equals 3. So my wholes is at 7. My vertical asymptote is at 3, and my excluded value are 7 and 3. In number 10, we're going to go ahead and 3, 39, and 90 all have a 3 in common. So I can GCF a 3. What's left over in the parentheses is x squared minus 13x plus 30. And the denominator can just be factored. So we have x minus 10, x plus 7. And now I'm looking for two numbers that multiply to 30 and combine to negative 13, so I can go ahead and factor that. So we have 3 on the outside, and then we have x minus 10, x minus 3. So there's the factors divided by x minus 10 times x plus 7. I can go ahead and cancel x minus 10 with x minus 10. So my final answer for the simplified version is 3 times x minus 3, do not distribute, divided by x plus 7. Whatever you cancel, set it equal to 0. So we have a whole at x equals 10. Whatever's left over in the denominator, take that and set it equal to 0. We get that x equals negative 7. So my excluded values are at 10 and negative 7. For number 11, you're going to have to factor the long way. So in your numerator, when you factor this whole thing, you're going to get, however you factor, 2x minus 1 times x plus 3 divided by 1 minus 2x. Now, check this out. 2x minus 1 and 1 minus 2x, these are opposites of one another. So you are actually able to pull out a negative 1. So I'm going to keep my numerator exactly the same. So we have 2x minus 1 times x plus 3. In my denominator, I'm going to pull out a negative 1. And this is going to change. So we have negative 1 plus 2x. Since they're opposites, you're able to cancel. And you're left with a simplified version of x plus 3 over negative 1, which you can also have as negative 1 times x plus 3. A little bit different. You can also have negative x minus 3. That's also the same thing. All right, so I canceled that 2x minus 1, set that equal to 0, and you're going to get x equals 1/2. And there is nothing left in the denominator. All right, negative 1 is an I equal to 0. So we have no vertical asymptotes. So your only excluded value is 1/2. For the final problem, this involves more factoring. I'm going to go ahead and solve this one. So I have 3 different ways that you can factor over on this right-hand side. You're looking for two numbers that multiply to negative 36 and combine to 9. When I go through the different ways to factor, go ahead and pause the screen and then complete the simplified version. Excluded values